I welcome him for this session. I also thank him for accepting our invitation to give a lecture regarding solid waste management. I welcome all the faculty from SAS, AVIT and other institutions, the students who are participating. I think this session will make us to somehow solve the problem of solid waste management. Each individual should contribute one or the other way to dissolve the solid waste management, solid waste which we are creating. So I hope this session will be an eye opener for all of us. Once again, I welcome Dr. Lakshmikandan for this session. Thank you. Welcome you, sir. You can talk now.
Thank you, madam. Thank you very much. So first of all, I would like to greet you all by wishing a happy Environment Day. And I think with the current corona pandemic and other natural disasters, it is upon us to save the environment. And I would like to thank all the faculty members, students, and whoever is present through this live webinar. Happy Environment Day. So madam has given my introduction. So most of my work is in the area of solid waste management only. So let me start the presentation now. Yeah, is it visible now, the presentation?
No, sir, it's not seen.
I've shared the screen. So is it visible now?
No, sir, no.
Okay, 1 second. Okay, is it visible now? Hello?
No, sir, it's not visible.
Okay.
Yeah, sir, now it's visible, sir.
Okay, so now it is visible, right?
Yes, sir, yes.
So can I start? Yeah. Of today is solid waste management. So we'll try to understand what is solid waste, how it is managed, where it is generated, where it goes finally. Actually, most of us don't know where it goes exactly. Finally, we just know that we dump the waste or we give the waste to some waste collector who comes to our area, and then we really don't know what happens to the waste. But it is creating a hell lot of mess which needs to be addressed and which needs to be solved by us. Otherwise, the future generations will be affected. So then we'll go by what are the rules managing for managing solid waste in our country. Maybe the what to say at each and every level, state wise, locality wise, community wise, and then what are the impacts of this solid waste on the environment? What are the bad practices? What are the hazards to the environment? And then finally, we'll see some possible what to say solutions or treatment methods that are available in today's date. So classification of waste according to their origin and type. So there it can be classified as municipal solid waste. Municipal solid waste is a waste that includes household garbage, mostly that is generated from the municipal area, household, what to say, residential areas, then construction, demolition, debris, sanitation residues, some packaging materials, etc. So these are classified as municipal solid waste. Today we'll be mostly looking into the municipal solid waste, as other types of waste are managed to some extent. But municipal solid waste is a huge problem because of its quantity and the what to say mismanagement, and what to say a lot of technical issues also. So we'll get into that. Then we have the biomedical waste, that is what to say the solid or liquid waste that is generated from hospitals or any research or treatment research activities, any labs, etc. Then you have industrial waste. Industrial waste is waste that are solid and liquid waste that are generated mainly from the manufacturing and processing units from the industries. Then you have the agricultural waste, which comprises mostly of the what to say waste from the farming and other agricultural activities. Then you have fishery waste, which is mostly all the what to say fish remains and whatever they clean and all the scales and all those things. Then you have radioactive waste. This is very dangerous. So you have separate rules for this. Radioactive, this is mostly the what to say byproducts of nuclear processes. Some processes are there which are what to say like chemical sludge, radioisotopes and all. They are what to say products of chemical processes also, but still they are radioactive or categorized under radioactive waste. Then you have your electronic waste, that is e-waste. That is mostly your what to say household electronics or daily used electronics, remains of that, maybe broken part of it, discarded part of it, etc. So this is how the municipal solid waste will look. So we'll be concentrating only on the municipal solid waste, how it is, what it is, where it goes, what are the properties of it, what are the main rules that are meant for maintaining or managing solid waste in an area, and then finally we'll look at the municipal solid waste will look like most of us know. So it is generated in the urban area, which does not have any further use in the society. So what happens? You generate some solid waste, then there is some collection and transportation. So you might be well aware of in the cities that there will be a collector who comes to the doorstep, or you might have to drop it somewhere near your house or in your locality. Then further that is transported to what to say a nearby area where it is segregated, or the segregated waste itself is transported. Then what happens to the organic waste? So nowadays, you might be aware that there is a what to say two-way system, two-bin system. So they take the organic waste separately and the inorganic waste separately. So the organic waste, they take it separately, and it mostly undergoes the anaerobic treatment or aerobic treatment, something like a composting or a biomethanation, and we get good products out of it like methane and other things. So there are some what to say other products like recyclables, like say plastics, then glass and some metals also. So these are actually taken to the landfill. There it is hand picked by the rack pickers, and then it is taken to the recycling industry, or they sell it to the wholesalers, and those wholesalers they take it to the industry. Then there are some inert materials which cannot be dealt with, so you don't have any use of it. So those kind of materials goes to the landfill. This is a simple what to say photograph of what happens in today's this thing. Something like all the what to say sweepings, then that are garden waste gets collected by the truck, and then it is transported, and then finally it goes to the what to say landfill, where it is segregated and finally disposed. So this is another what to say pictorial view of what happens. Like there is a primary color segregation thing that happens at the source. So more degradable, non-degradable, all those things. Then there is a what to say door to door step collection of these waste. Then it is transported. Then it is maybe in some cases where you don't have any facility, it is taken to the transfer station, a facility where the waste is temporarily stored and segregated and finally taken to the processing units or to the what to say landfills. And then it is taken to several what to say units, like maybe sorting, compacting, or composting. Then maybe what to say vermicomposting, material recovery facilities, RDF, etc. And finally some of the things finally reach to the landfill. So you can see here something like close to 45% of the total waste is landfilled. So out of that, 30% is rejects, 15% is rejects from the recovery facilities, etc. Right. So now coming to what are the different processes that are available for treatment. So if you take MSW, normal, it is collection, segregation, transportation. Then after that, coming to the processing, you have recycling and recovery. So that is one part. So if you take the organic part or the inorganic part, then you have composting, incineration, that is burning of waste at 1500 degrees. Then you have biomethanation, the complete organic waste goes into this process to generate methane. Then you have RDF. This also, the dry waste is packed, something like plastic, textile, paper. So these things go to the industry. So they use it for burning the, kiln, or they have their burning process. So they use it in that. Then you have pyrolysis and gasification. These are also energy generating processes, basically. Then you have final this thing that is called the disposal. So we'll just go into detail a little bit. Okay. So now we have seen what is solid waste, how it is managed at a local level. Now we'll come to know what is the the rules that are there, that you should know or everyone should be aware of. So there is this rules called Solid Waste Management Rules 2016. There is a newer version of this also, but the basis is this only. So you know that what and all is the important part of this is like, there is a user fee in this. There is a spot fine if you don't follow few principles. Then the recyclables should be going for recycling. It shouldn't be taken anywhere else. There is a stringent norms for incineration if you are going for incineration. Then there are separate standards for waste to energy projects that are included in this. And when you incinerate waste, you must be knowing that dioxins and furans are a common emission products. So that has to be taken care. And how it has to be taken care, there is a standard procedure given in that. So the rule talks about all these things. There is also this rule also talks about the different authorities who are generating the waste. Say, for example, responsibility of the waste generators and the authorities. It has been introduced in this. So this is a very good initiative by the government. So government is also keen on integrating the rack pickers or some kind of people at the lower level who are involved in this waste segregation or waste cleaning part. So that is also being considered, and some incentive is also being provided to that. Then it also has a detailed criteria for setting up any solid waste processing facility or treatment facility. So all these things are being introduced in this. Then there is a fixed tariff or charges that is given to this waste to energy generation, waste to energy plants, people who are operating this. There is some kind of subsidy also given to this people who are operating this. Okay. Now this is also extended to the urban local bodies also. So you should know that, in your zone, who is responsible. So you can also take an action as an individual. Say, for example, in urban setup, such as towns and this thing. So it is declared by the Registrar General and Census Commissioner of India. Then notified areas and industrial townships also are also included in this. Then areas under the control of Indian Railways, airports, etc. Defense establishments also, special economic zones. You might have heard of the SEZ and all those things. That is also included in this. Then you have your separate state and central government organization tariffs, etc. Then also it includes also this temples, pilgrimage places, tourist places, institutions, etc. So what this rule says is that you have to segregate waste at a source. Then because segregated waste is easy to handle and treat, so you have to segregate into wet, that is biodegradable, then non-biodegradable. Then what do we call as that is a domestic hazardous dry waste. So as it is shown here, there are three colors of bins that are kept. So the green one is for the biodegradables, the yellow one is for the non-biodegradables. Then the domestic hazardous, such as the batteries and other things, can be put into this. So this is a new norm that these people have created. This has to be followed by us. So also there is other rules, such as there shouldn't be littering of waste, burning of waste, etc. Then construction and demolition waste should be separate, and separate use of fee as per the bylaws. Also, local body can charge according to the large gathering events or any what to say event in such case. So different authorities now come into picture, like the Ministry of Environment, Forest and Climate Change. So they do have a what to say a role in this. So they have to constitute a central committee to monitor and review this every year. So Ministry of Urban Development also should plan this national policy on solid waste management. So Department of Fertilizers Chemicals should also assist in the development of those fertilizers, because compost is generated as a product of this composting as a what to say replacement for fertilizers. So that is why Department of Fertilizers and Chemicals is coming in. Similar cases with the Ministry of Agriculture. So in case of power ministry, there is some amount of power that is generated because of this waste to energy products also. So they also have to what to say come in and fix their tariff. So the coming to the responsibilities of the local authorities at the local levels, they have to prepare a solid waste management plan for their state or for their what to say districts. So that has to be done by these people. Then arrangement of door to door collection of the segregated waste. So that has to be done by these people. Say that might be through a truck or through a tricycle or whatever means they feel like. So that is the responsibility of these people. Then also setting up of this material recovery facilities and important what to say bylaws and all those things should be done by these people, local authorities. Then also some of the other what to say roles that has to be played by these people are the what to say safe storage and transportation of domestic hazardous waste. So provide training to the waste pickers and collectors. Then what to say separate collection and transportation for the different types of waste. Then you have what to say facilitate construction and operational maintenance of the solid waste processing units and facilities. So these also have to be looked into by the local authorities. Okay. Now, the other part is they have to make adequate provision of funds for capital investments, because they are collecting a fees from us for this. So it is their responsibility to do this, and they have to prepare an annual report based on these things. Then collection and transportation by the local authorities, as mentioned earlier. So it is like for wet waste, it has to be daily. For dry waste, maybe it is like once in 2 to 3 days. Then streets waste, street sweepings, it is like as and when. So it shouldn't pile up on the streets. So that is a major aim. Then domestic hazardous waste, again, it is like according to generator, maybe once in 2 to 3 days. Coming to the construction and demolition waste, it has to be collected separately as and when generated. And similar is the case with the garden waste also. So these what to say different types of waste and the timings of their collection has to be done by these people, and it is very very important. So you can also complain and take actions if it is not done. So you can go to the local authority and say that maybe some of the waste is not collected in your area. You can take up these kind of issues as students and even other people, faculty members. So they gave some time for what to say the identification of the facility and all those things. So according to that, so the land for processing unit or setting up the what to say processing facility is like 1 year. Then ensuring segregation of waste, it should be done within 2 years. Then setting up the sanitary landfill. So what happens is sanitary landfill is nothing but a secure landfill wherein it is ensured that none of the what to say waste goes out to contaminate the soil, water, or air. So it is put in such a it is encapsulated and put in the earth in such a way that it doesn't contaminate anything. So this is the time given to the what to say authorities according to this rule. So there is some improvement with respect to the recent rules. So they have given some technical things like how what is a gas collection system should be a passive gas collection system or active gas collection system. What is the improvements in that liner system? How it has to be what to say put, and what is the improvement in that? So those and all things are being put in the recent ones. But if you see, there is not of much change between the 16 rules and the present rules, 1819. Okay. They have also given some specifications for landfill sites. So landfill sites should be large enough to last for at least 20-25 years. Means that you have to design your landfill for 20-25 years. So during this monsoon, you have to take care of the waterlogging issues. And other conditions are also there, like it shouldn't be close to a river, like it should be at least 100 meters from a river, it should be 200 meters from a highway, then habitations, public park, water supply system. That is why these landfills are most usually kept on the outskirts or outside the cities, so city limits. And it should not be permitted under the floodplains or wherever there is some agricultural thing that is happening. It shouldn't be permitted. Also, it shouldn't be close to the airports. So these are some specifications specified by the rules that should be followed while setting up a landfill. Because ultimately, what happens is, like as we saw, something like 45-50% of the waste comes to the landfill after everything. So this is very important. So also a buffer zone needs to be created. That is very much important. So there is a buffer zone created in Nagpur for this landfill site. There's a landfill site called Bandewadi landfill. So there is a buffer zone created. So similar buffer zone has to be created for each and every landfill so that the contamination doesn't go outside of that, and it has to be monitored regularly in the buffer zone. Okay. Now coming to landfills, let us understand what is a landfill. So landfill is a most commonly used method for solid waste disposal. Finally, so you can if you see the components, so it has a liner, it has a cover system, it has a leachate collection system, it has a leachate recirculation system, it has a landfill gas control system or collection system. So why these systems are there is that it shouldn't pollute the underlying soil, then the groundwater that is there, and the air. So that is a major aim of this. That is why these many components are there. And I'll go to the figures, then you'll understand better. So you can see a modern landfill here, typical view. You can see the liner and cover system. So the black line that is there, that is the cover system and the liner system. So the bottom thing is called the liner system, and the top thing that covers is called the cover system. Because this is called by different names because each and everything has a different specifications. I'll show that when I come. Go to the other slides. Then you have your leachate collection system. So what happens is in a landfill, there is a kind of pit kind of thing that is made where the leachate gets collected, and there is a pumping arrangement that is made. So the pumping arrangement pulls out or sucks out all the leachate from the leachate pit, so that because if the leachate remains there, then it might percolate or it might crack the liner system and go and uh, further contaminate the groundwater. So it has to be removed at regular intervals. Then there is a gas recovery system or collection system. So you can see a long pipe kind of thing that is installed. So that will be a perforated pipe. So that is installed, through which you will have your gas collected. I'll go to a 3D picture of this. It will be something like this, because you know that in a landfill, solid waste is filled in a stepwise or cell-wise manner. So in each and every cell, there will be a piping system placed, the perforated pipe system, that is one for a leachate and one for gas collection. So finally, when everything is covered, there'll be a leachate collection storage system and there'll be a gas collection system. So you can see on the left, there is a gas collection system that is connected to a generator, and that genset is connected to the grid. So as of now, I'll tell you that IC engines or gensets are used mostly, and the efficiency is around 30%. That is whatever gas you're getting, 30% of that is converted into electricity. That is the present efficiency rate. So also there is a groundwater monitoring station there. So this is very, very important. It is a mandatory now. It has been made mandatory, right? So this is a live picture of a landfill site in Bangalore. What we studied now and what we see now practically, there is a lot of difference. So you can see how the waste is being dumped. This is in a very, very irregular and non-organized manner. You can see that there is a liner being put, but on the left-hand side, the liner is torn. On the other side, there is a truck that is putting waste into it. It shouldn't be like this. So there should be a ramp made, and then the lorry should or the truck should get into the ramp and then deposit the waste at the bottom. So what this does is this creates a huge lot of problem later. I'll come to that. You can also see some leachate that is stagnant over there. This is a live example of how it is managed in India in a very pathetic manner. These are some examples of landfills across India. So the top one is from Mavali. You can see that the waste is also not covered. They have just put it. maybe half of it is not covered. On the right hand side, they have not covered, the leachate is seeping through that. Then you can see a cross section of waste on the third one, where all the plastic and waste is like dumped just like that without even covering it. On the right hand side, you can see the leachate seeping from these waste. So this is a very, very serious issue. What happens is that we talk about landfills. After segregating all the waste, it goes to the landfill, and these kind of issues pop up. So this leachate, what it does is, there is when it mingles with the groundwater, it contaminates everything. This is the segregation facility at the landfill site itself. You can see that the textiles, papers are all separated. Then you have at the right corner a composting unit. Then you can see that composting unit, that a compost that is being generated and packed. And finally, at the last figure, you can see the inerts. So they are using this inerts also nowadays for maybe say in making roads or some kind of fills. So these kind of uses have come up now, but again, it is very, very limited and restricted. Okay. Coming to the current situation in India, the total number of existing dump sites is around 2000. Um, Means the covered dump sites is only 40. So you can see the ratio, how it is. So the capped ones, or the covered ones, are the safest ones. The rest others is not safe, because they are generating methane, they are creating greenhouse effect, they're creating letting out methane and carbon dioxide into the atmosphere, etc. Then dump sites converted into sanitary landfills, it's only 21. So you can see the ratio again. So the landfill sites identified for future is around 900, so close to 1000. Then constructed is around 100. Under construction is around 75. Then landfills in operation is around 200. So this is the status of present landfills in India. Okay, now let us go deep into this. What are the issues with respect to landfills? Why it is such a problem? First, let us see what are the properties of waste that are very much important in assessing the waste, or deciding the treatment technology for waste, or in designing a landfill, etc. Then we'll go to the gas and odor control. That is one of the major problems. Then again, fire and explosion. That is also a major problems in landfills. Then you have your leachate characteristics and seepage, groundwater contamination, etc. Finally, we'll see a landfill design and final filling. That is a case study. I'll just take you through a case study how it is done. Okay, we'll start with experiment and properties. So first comes the physical composition. So it is categorized into organics, clothes, then leather, metal, wood, all these things, paper, plastics. So here what happens is that the it is a mixed waste in the landfill. So in the landfill, they try to produce compost. So what they do is they don't separate waste by hand there. Only the big particles that is greater than 20-30 centimeters, the big chunk, that is being removed by the rack pickers. Other things, it is like usually mixed there, and they send it to a segregating unit. Segregating unit usually contains this trommel kind of facility, which will segregate the smaller particles. Like 100 trommel is there, then 75, then 35 then 16 and then 4 So whatever passes through 4 is regarded as compost, and the rest rejected part in these processes or through these trommels. Trommel is nothing but a sieve kind of thing, round or sieve kind of thing. So the rejected part again goes to the landfill. So this is why the physical composition is important. We have to know how much of physical composition is there, organic component is there, so that how much of waste compost can be generated out of it. And before sending it to the landfill, we should also have an idea how much of paper and plastic is there, textile is there, so that that can be converted into other useful products, such as refuse derived fuel, etc. Right. So this is total volatile solids. Again, this is a simple experiment that you take waste and you keep it in your muffle furnace, heat it at 550 degrees for some time, and then you see what it remains. So this will give you the organic content on the inorganic content. That is the volatile solids and the non-volatiles. So what remains is the non-volatiles. So the particle size distribution is important because few treatment units, they depend on this. Say for example, composting, what is a refuse derived fuel, the particle size distribution is important. So it is very important to find out the particle size distribution of waste. So here I have taken only 20 waste and I've done it because the other part was already done by the trommel and it had already been sent to the landfill. So the specific gravity is also important because specific gravity gives an idea about the density of the waste. BMP test. Now, what is this BMP test? BMP test is biomethane potential test. So the waste that is there through anaerobic degradation, it generates methane. So what we do is we have to assess this total biomethane generation potential of waste, because it is very important. The organic content that is present, if it goes to the landfill directly through anaerobic degradation, it will generate a lot of methane. That is a greenhouse gas, and it will it is something like 21 times worse than CO2. So it will cause global warming and also other environmental hazards, right? So this is a lab scale experiment that was performed at my place. This is, you can see there is a waste mixed with the inoculum, that is bacteria, and then there is a methane collection system that is there. So at the bottom you can see the measuring cylinder, graduated cylinder, where the water will be displaced. So the water, how much of water displaced is the gas generated. So I'll just show you some results. So this is how it is plotted. It is plotted using a sigmoidal curve. So that is a thing that represents the anaerobic degradation properly. So here you can see the rate of gas generation is around 0.84 milliliter per gram of dry volatile solids. So per gram, it is like almost 0.84 ml of gas that is being generated. That is the rate for Indian partially degraded waste. So here I've just put this elemental analysis, that is ultimate analysis. You can see the percentage of nitrogen, carbon, hydrogen. So you can see the percentage of carbon in the initial MSW, that is municipal solid waste. It's around 19%. So this after degradation and other processes, it gets reduced. So here I've just performed an experiment in a dry condition and in a bioreactor condition. Dry condition, I don't supply any water. Bioreactor condition, I just keep supplying water at some regular intervals. So just you can see how the degradation takes place, and it is getting reduced. So the carbon reducing is the most important part in this. Okay, so I'll just tell you about an experiment that was conducted in my lab to measure all the components simultaneously. Say, for example, a replica of the landfill setup was done in a 3-meter height setup. So here you can see the waste in between. Bottom there is a liner, and also top there is a liner. So there is provision for leachate collection. You can see the bottom top, there is a leachate that is being generated and collected. So this was characterized. Then you can see the long tube kind of thing, that is a water displacement method for gas collection. So that is a landfill gas. So landfill gas has both methane and carbon dioxide. Methane is around 45-50%, and rest is carbon dioxide. And you also have some traces of ammonia and other gases. So there is a uh, a temperature sensor placed inside this. So that will measure the temperature, that will measure the moisture content, that will measure the settlement that is happening, and that will collect the gas whatever comes, and that there is a GC placed on the other side of the table. So that is a GC, and the gas whatever comes, we'll be testing it. So we come to know the composition of that composition of the landfill gas in the GC, right? So I'll just show you the results. So this is a temperature monitoring of that. You can see the temperature. It was monitored for around 450 days. You can see the peak temperature around 32. So this is the peak temperature with water being circulated every 5 days or 8 days. So without that, it could have like raised to maybe 50, 55. I'll show you the field temperatures also. These are some results actually. So you can see the pH, it actually was kind of bit alkaline in the beginning, and then it came into the neutral range. Then you can see all the parameters like very high TDS, like something like close to 60, 70,000, and then from that it comes down to 15,000. Similar is the case with conductivity, and then case with alkalinity also. So after each and every recirculation, the the concentration of these parameters reduces. We just did this experiment to find out how good a leachate recirculation could be. So we didn't recirculate any water. We just recirculated the leachate that came out of it. Then just to see the stabilization part, we just saw the calculated the BOD to COD ratio. So it reduced from 0.332 to maybe less than 0.25, but still there was some thing to be degraded. Then also we calculated the sulfate to chlorine ratio. So you people as chemists, you must be well aware of all these components. This is again to check the stabilization. So it reduced from 0.08 to 0.02, indicated kind of decent stabilization. So finally, in that setup, you can see simultaneously the gas production and settlement. I'll just explain you the relationship between this and that. So what happens is like you can see the settlement, total settlement, it is like coming down. So what is settling means the whatever organic component was present in that, it is getting converted into methane and carbon dioxide. So the carbon is getting reduced. So similarly, if you see the gas collection, gas generation, it starts after maybe say 30-35 days, but then goes on increasing. So what is happening is you can see the reduction and settlement and gas collection interrelated, because whatever is getting removed from the organic part, that is getting converted into either COD of the leachate or methane and CO2 of the gas. That was a very important part here. So you can see around collection was around 120 liters, and settlement was around 20 to 26 part. So we did a small mass balance by generating equations, by calculating the molar compositions of all these parameters like C, H, N, and all those things. And then we did a mass balance, and it was like close to accurate. There was an error of around 5 to 6%, which is quite acceptable in research. Okay, now this was whatever I told. This was a lab kind of lab setup where we did several experiments, like initial starting from the physical composition to final setup where we could calculate the settlement and gas generation. Now we'll go to the gas control, gas and odor control. Why is landfill gas such a problem at landfill sites? This was a previous one was a lab thing, so we were able to collect it because most of the parameters were controlled. But in a field setup, it is not like that. So landfills are worse than incinerator when it comes to climate. So there is several studies being done wherein it says that if a landfill gas capture rates are more than 50 to 70%, it is going to be very, very harmful. Then the capture rates are also lower of the gases. Capture rates of these gases is also lower. Then let us say what is this landfill gas? As I said, it is like not only methane, it is like CO2 and methane. Also other trace gases are also present. Say for example, these are all toxic contaminants. Say halogenated components trichloroethane, vinyl chloride, etc. Then you have sulfur components. Majorly H2S is one of those. It is a corrosive gas. That is why before sending it into a genset, they actually try to remove that. They scrub the H2S and then only they send it to the genset. So this is a typical landfill setup which is having a gas collection system or a recovery system. So you can see the pipes installed inside the landfills. So these are all perforated pipes, and this is connected to a recovery system. So either you have a centrifugal system which will pull in all the gas, or you will have active this thing. So it will automatically generate, and the gas will automatically flow in on its own base. Okay. Now coming to the options, what are the options? Flaring is nothing but slight combustion. You cover all those things, and when the gases comes out, you just flare it, you just burn it. Now why this is done is maybe the methane content would be very less, or it would not be financially or financially and economically viable. That is why they go for a flaring system. Then IC combustion engine, that is when you have a good amount of methane that is coming out, then you go for IC combustion engine, which is around 30-35% efficiency. Exactly, I think it is 33. Then again, the same thing, turbine, boiler, all those things, when you have a good amount of methane coming. Then some people also go in for hydrogen production with this. Okay. Now landfill gas energy emissions. We just look at these what to say emissions and what are the what to say effects. Carbon dioxide, carbon monoxide. You can see it is like 2.7 times worse. As you know, CO2 is a considered as a what to say standard thing. So NOx, nitrogen oxides, it is like again the same thing, 2.5, 2.6. Sulfur is 3%, methane is 3%, dioxins and what to say furans, it is considered the worst thing as it is like close to 41% what to say worse for the environment. Now coming to this landfill gas, it can be thought of as a resource. Like you have your landfill, there is a gas that is being generated, and then you're using it to generate electricity through a genset or by other suitable means. Again, that electricity is being separated to your homes. Now this kind of what to say system is followed in a lot of places in US. So what they do is they don't segregate the waste, they just take the total waste and then they dump it into the landfill. And what they do is in the landfill, they when the methane comes out, they just collect it and then they burn it, and then they generate electricity that is being supplied to the cities, or even at least in some cases that is being used to manage the landfill facility itself. But such kind of thing is not yet come in India. They're trying to collect, but it's not successful. Let's see to what extent we can do. Right. So the next part is because of this gases, if it is not collected properly, if it is not what to say extracted properly, this might lead to a lot of what to say fire incidents at the landfill site. So I'll just categorize landfill fire. So it is like you can say spontaneous fire that happens on its own. Then you can say deliberate fire. Deliberate fire is usually done by this landfill operators. What they do if there is a lot of waste that you're not able to handle, they'll just deliberately fire it. So that the basic idea is volume reduction. And sometimes there is an accidental fire, maybe some kind of battery is dropped in, lithium ion battery, or lead battery, then it comes into contact with some what to say chemical, then it catches fire. Those kind of incidents happen. Then if you take the spontaneous fires, you can they are again classified into subsurface and surface. So again, if you go little deep, then there are a lot of biological and chemical factors. So on the right hand picture, this is a what to say uh, this is a site in Delhi where the gas was coming, and somehow by when the methane comes into contact with air, it has started catching fire and it's like burning continuously. I visited this site in last year November, so you can see the what to say effect, the amount of uh, gas that is being generated. So these things which are burning, it has to be collected properly. If it is collected, then we can make use of it. These pipes are gas extraction wells actually, so they've just left it as it is. So just to understand what is this why is that thing coming into picture, because you people are all chemistry students, you should be what to say knowing all these things. So when there is a aerobic degradation, this C6H12O6 is glucose. So when it degrades, so you have a what to say enthalpy of this much, that is heat generation of this much. And then when there is an anaerobic degradation, again there is a what to say heat release. And then when further there is a chemical oxidation process, again there is a heat generation. So when you go into detail, all these processes contribute to this what to say heat generation, and finally lead to the fire accidents. These are some locations from where I collected the data. I'll show you how it starts. So it starts by smoldering. You can see slight smoke coming initially, and then it starts to burn. So this is a Ghazipur landfill in Delhi. So I just wanted to show you the temperature at the landfill site. So whatever pipes I showed you, there you can see the temperature. It's around 369. So here where the smoke is coming, it's around 258. So these places, the temperature is so high. And that is because of these, what to say, whatever I showed, no? The chemical reactions and the heat generated out of that. That is the reason for this rise in temperature. So here you can correlate how serious it is. Okay. Now let us go into this leachate characteristics. Okay. What is leachate? Leachate is nothing but when water enters or mixes with this waste and then seeps through it and then finally comes out. It comes in a brown colored what to say form. You might have seen. So what happens is in landfill sites, they don't cover it usually.
whereas the rule says that it has to be covered. So sometimes even if they cover also, because of this rain, water percolates, and when it comes out in a, what to say, brown color form. It is nothing but it gets mixed with the waste. It takes along with it all the nutrients that is present in the waste, and it comes out. So just to see the concentration, this is a typical site in Bangalore. So you can see the leachate concentrations. You can see the TDS, you can see the POD, COD. COD is around 21,000. You can see sulfides, you can see chlorides around 8,000. It's very, very high concentrations of the leachate. So here, this is a very, very, what to say, sensitive and serious issue which needs to be addressed. All the metals also, there are some metals also present, iron, zinc, and all those things, just to give an idea how the leachate is. So these are some pictures of landfills from different parts. So you can see the leachate coming out from the what to say, dumps. And then what happens is this leachate actually finally goes into some, what to say, low-lying area. So you can see one area which is meant for actually groundwater collection, but the leachate is all what to say, collected over there. And this again will finally contaminate the groundwater. This is the most what to say, serious issue about the leachate. Okay. Now we saw all the, what to say, practical problems of leachate, gas, and other issues. And I'll take you through what to say, quickly through a case study, how a landfill is designed, how it is to be accommodated. So if you take a landfill design, the what to say, pre-design part, it is very, very important to assess the landfill capacity. As I said, it has to be designed for 25 years. So you have to assess the landfill capacity, so that you have to what to say, construct accordingly. Then you have your liner and cover system, and then you have to have your leachate collection system and gas collection system. So this is a site in Bangalore. So we just took some what to say, details, like what is the waste collection per day, 500 tons. Then inert waste generation is around 100 tons. Then the topography is variable. How is the subsoil? What is the groundwater level at present? It's like 213 meter deep, etc. What is the average total rainfall, etc. Right. So landfill capacity, like we calculated according to the what to say, generation, and it was around 10 years. So it will be what to say, going on for 10 years. So here is the details given. So you can see this. So the total waste and volume that can be accommodated in that is around 3,62,000 cubic meters. Based on all the parameters. Right. So this is a typical, what to say, cross section. So normally what happens is it's like constructed something like below the ground and above the ground. So this is a similar thing. So you go something like 12 meters or 13 meters below the ground, and again the same thing above the ground, right? So this is a typical what to say, cover system I was talking about. So you can see the bottom is a waste layer. On top of it, you have different layers. A GSM layer, that is a separation layer mainly, and then you have a drainage layer, because whatever water comes in, so it will flow through the drainage layer. It doesn't get mixed with the waste. That is a major reason for that. Then you have a geomembrane. Then you have a, what to say, a gravel layer, and again top of it you have a fine loamy sand layer, and or a vegetation layer, that is called. So this is the components of a cover system. Okay, this is the components of a liner system, that is at the bottom. So you again have a, what to say, to start with the drainage layer, then separation layer, that is a geotextile, then a geomembrane, then a GCL, 6 mm thick GCL. Right? GCL is nothing but a geosynthetic clay liner. That is a clay liner. So these are the specifications recommended by the CPCB, Central Pollution Control Board. So this is the thing. So before what to say, putting these liner and this liner and cover system has to be analyzed for total quantity of leachate that will be generated maybe at the end of 25 years. So HELP is a software. It is nothing but hydrological evaluation of landfill data. So this is what to say, used for this assessment. So you can see the total volume of leachate that will be generated is around what to say, maybe 1.2 meter cube at the end of 30 years, something like that. So it is safe. So if it is more, then you'll have to again what to say, change your composition of the liner and cover system. Right. So there is another software called Pollute. This is majorly for the contaminants, whatever you saw that are present in leachate. Say for example, nitrite, chloride, and all those things. You have to make sure that it doesn't get mixed with the groundwater, or you have to see like simply how deep can it go. So Pollute is a software used for that. So you can stay. I've just taken some what to say, initial concentrations. So initial chloride concentrations around 10,000, and see to what depth it goes and in how much time. Uh, So I don't know whether this figure is properly visible to you, but I'll just explain. So this is the like the pink line shows the what to say effect after 30 years. So after 30 years, it has gone to a depth of around 20 meters depth. So the maximum distance that that the contaminants can travel through the liner system in 30 years is around 20 meters. So this has to be correlated with your what to say groundwater depth. So the groundwater depth is around 200 meters, and you're getting as 20 meters. So you can assume that it is kind of safe, whatever liner system you're providing, and the place where you're putting your landfill is a safe option. So the second part is when you're constructing the landfill above the what to say ground level, the slopes stability is very, very important. So for design of the slopes also we what to say check in like how it has to be and all those things. This is a design of slopes, how it has to be. Then you can see the slopes like 1:3 slope is provided. At the bottom 1:3 is provided. Also at the top 1:2, 1:3 it will be provided. I'll show you in the future slides. That is also very important. This is the stability analysis. You can see the portion where above the ground there is a rise, and the factor of safety it is showing in the green zone. So the factor of safety is around 1.8. Anything above 1.5 is considered as safe. This is a what to say typical section of a landfill. So this is the thing. So you can see how it is being constructed according to a what to say specific site design research. So you can see one side there is a rise, there is a fall. 1.3 1:3 is a standard slope that is being followed, and these are the dimensions that are provided. So coming to the leachate collection system, after designing this, a lot of parameters have to be considered like rainfall, surface water, groundwater, and all those things, right? So there is a what to say a way of calculating the leachate also in the CPHO manual. You can refer that also. So according to that, it is being calculated like what is the quantity of leachate that is expected per day, around 160 meter cube per expected per day. So you have to design a leachate collection tank according to that, and then you need to have your pipes and what to say other connection pipes, etc. according to that. So here we are considering something like a 150 diameter pipe, that is a perforated pipe. So I'll just show you the figure. So you can see just the what to say parameters consider the total area of the landfill. Accordingly, what is the average precipitation in Bangalore? Then how it is calculated, right? So the spacing between the leachate collection pipes 20 meter. Let's go to the figure. So this is how it is. So in this figure, you can see the vertical and horizontal what to say piping system that is being provided. So a zoomed in figure is given on the right hand side. So you have your drainage collection drainage layer, and on top of it you have your leachate collection pipes. So through these pipes, leachate is collected, and then a pit is made at the corner of the landfill from where it is being pumped out. So then you have a plan how it is to be operated landfill. So you have some what to say rules and regulations like you consider all the terrains, topography of the site, etc., etc. And then see this is how it has a ramp has to be made to deposit the waste at the bottom, and then you have to fill it in strips and in cells. So something like this. And then finally, it should be looking like this. So this is how a practically landfill is, what to say, designed, operated, and finally filled. So this was successfully done in Bangalore. I wanted to show you all the photos, but since time is up, I'll think I'll conclude with this, right? So thank you.
So thank you, sir.
If you have any
Sir,
questions,
we have
I'll
some
answer.
questionnaires. We have some questionnaires from our participants, sir. The first question is how to dispose radioactive solid wastes.
Excuse me, I'm not able to hear you.
How to dispose radioactive solid wastes.
How to dispose?
Radioactive solid wastes.
Sir, usually what happens is the radioactive solid waste, it goes to the what is a hazardous waste landfill. And there also they have a set of procedure that is being followed. What they do is they first stabilize the waste. So if you take hazardous waste, then it is like characterized, I think you must be knowing corrosive, reactive, those kind of things. So it shouldn't be having any of this what to say characteristics. So first they will check, then they'll try to stabilize the waste, and after stabilizing it will go to the landfill, hazardous waste landfill.
Yes, sir. So the next question is how e-wastes can be disposed electronic wastes?
Sir, there is a separate rule for disposing of e-waste, because initially what was done is they did not have a separate rule kind of thing. Now they are having a separate e-waste mechanism, because most of these e-waste, they have lot of useful metals and useful components that is present there. So they try to recover that.
The next question is, sir, how to dispose mercury content wastes?
How to dispose?
Mercury content wastes. Mercury.
Okay. Mercury. So again,
Yes,
it is the
yes, sir.
same thing, because lead, mercury. What they do is they sometimes use it in I think lead is being used in the dental colleges and dental hospitals, and mercury is used in the chemical industry and all those things. So again, what they do is they take it to the hazardous waste landfill. If something is recyclable, or if some part of it can be used, then it is a different issue. If it is not usable or not extractable, then it will go to the hazardous waste landfill.
Yes, sir. Thank you, sir. One more question, sir.
Yeah,
what is the technology to reuse the carbon dioxide?
there are a lot of technologies for reusing, but I don't know how far it is successful at the field level, because carbon sequestration, fuel cells, then fuel gas, a lot of things are being done.
I hope this is only for plantation. Tree plantation is primary one, isn't it?
Yeah.
Yes, yes.
Yeah.
So one more question, last question, sir.
Yeah,
How will you
please,
dispose? How will you dispose the pharmaceutical solid wastes, medical wastes?
You mean to say the pharmaceutical
The
waste
pharmaceutical
means,
byproducts are coming. How will you dispose the pharmaceutical byproduct solid wastes?
actually they at present they are not having any separate rules for disposing that. But what they are telling this pharmaceutical companies is a treatment facility in their wherever their industry is having, or industry premises. So they have to give a treatment, and after a degree of treatment only, it will go out to the effluent treatment plants, or even to the other places. So as such, they are not allowing for disposal directly, because we are dealing with a lot of pharmaceutical industries. They are again coming up with a lot of things. Sometimes some places this common CETPs are used. Some places, if it is a specific thing, then they are having their plant effluent treatment plants of their own in their premises. So after a degree of treatment, they allow it to go to the maybe common effluent treatment plant outside, or to get mixed with the hazardous waste leachate.
We got two more questions, sir, please.
Yeah, please.
So how to degrade the solid waste by genetically manipulated microbes? Is it costly?
No, it is not costly. I'll tell you, because nowadays composting is being done at a household level, and you will get that microbes that is in the form of a powder. So it's like I think, if I'm not wrong, it's 60 to 80 rupees per kg. So because this mini composters and all those things have come in, something like close to 5,000 rupees, you have a composter close to 2.5 kg capacity. So there is a ratio that is being mentioned. So if you can use those microbes, and then it will degrade, it will get degraded in a week's time, 3-4 days time, and then you can use it for your as a manure in your not if you are not you're having apartment kind of, as a manure in the pots also. So that is come up nowadays.
So one more question, sir. What is the method adopted to do deliberate fire in the land filling area?
There is no method adopted in the area. See, actually, this deliberate fire, what happens is sometimes it is caused by the rat pickers who smoke on the landfill site. So they might be smoking, and then by mistake they would have thrown the cigarette or BD or whatever it is. Some places, the landfill operators, what they do is they deliberately put fire on the on the dried part. Because we have interviewed almost most of the landfills across India: Delhi, Bombay, Gujarat, Tamil Nadu, Bangalore, then even Mumbai. So what they say is sometimes the load is so much that they're not having place. I imagine that there is a problem in one of the landfill facilities in Chennai. So it has to be taken to the other landfill facility. Obviously, the load on the other landfill facility will be too much. So they're falling short of space. So they don't know what to do.
So what they do is they just burn off a dry part. So what the basic aim, what they say, is the volume reduction, because once it reduces to ashes, they can put in fresh waste there. So that is the major thing that is being adopted. They just take the matches and matchbox or whatever means they have. They just put a fire to that. That's it.
Last question, sir. Which is
Yeah.
a most effective method for disposing solid wastes?
What type of solid? Are you mentioning municipal solid waste or?
The mention only solid wastes. I think that depends upon the solid, isn't it?
Yeah, that is why I'm asking.
But the question
Because
is
if it is
given
a
only.
municipal solid waste, then yeah. See, there is this. If it is a municipal solid waste, then again it has to go through a lot of process. There are again a lot of loopholes in the current rules also, because they are not mentioning the waste that goes to the landfill, how much of organic content it should have. They're just mentioning that there has to be a pre-treatment, something like a composting or other pre-treatment has to be done before it lands up in a landfill. And somewhere they say that no organic content should go to the landfill, but that's not the case practically, because we have monitored almost all the landfills. Something like close to 30 to 45% of organic waste still goes to the landfill, because on an average, if you see, the general organic content of fresh waste in India is around 60 to 72%. So these people are removing that initial 10-15% by composting, but again the rest 45-50% goes to the landfill only, organic content. And in similar cases with the recyclables, big parts are being removed by the rack, because small parts are ignored. Again, it goes to the landfill.
Last question, sir. I got
what
one more
according to
question.
me-
Sorry, sir.
Yeah. Please.
Sir, how to dispose silica gel after using in column chromatography? Silica gel after
Silica
using in column
gel.
chromatography.
Do you have to dispose it? You can actually right?
I think we can reuse it. I think so.
Yeah, because see, I think recently one technology what IIT Madras developed is they tried to get water from the atmosphere. So what they are doing is they are using the silica gel there. So they place the silica gel there at the night or in the morning when the dew comes. The silica gel sucks in or captures all the water. And then in the daytime they slightly maybe heat it up, or slightly when the temperature increases, it releases all the water. So it's being used again and again. You can use it if I'm not wrong. And but again, it depends on for what purpose you're using. If you're using for any chemical thing, then that needs to be looked into.
Thank you, sir. Thank you, sir. Okay, thank you, sir. On behalf of Chemistry Department, School of Arts and Sciences, Vinayaka Missions Research Foundation, AVT Campus. So thank you, sir. Thank you very much for your wonderful webinar on solid waste management. In the short span of time, you've given a lot of information on municipal and hazardous waste management, landfilling engineering, waste to engineering system, water and wastewater treatment technologies, and advanced wastewater treatment. So you've given a very clear explanation on this one, sir. This is an eye-opening session on this today's Environmental Day. So it's a very, very important thing nowadays, sir. On behalf of management, we thank you very much. We thank all the participants who has given a valuable question and got the very good answer from the speaker, Dr. Lakshmikant, sir. Thank you, sir.
Thank you very much, one and all. Thank you. And once again, happy Environment Day.
Thank you, sir.
Yeah, thank you.